Hello students, in this session we are going to learn about superposition theorem. So starting with the statement, the superposition theorem states that in any linear active bilateral network having more than one source, the response across any element is the sum of the responses obtained from each source considered separately, and all other sources are replaced by their internal resistance. The superposition theorem is used to solve the network where two or more sources are present. So, let us see how to use this superposition theorem for electrical networks. So, this is the first problem which is in December 2019 and Jan 2020 exam. So using superposition theorem, find the current through 8 ohm resistor. So in the circuit, if you observe that there are three resistors, one is 20, other one is 10 and the third one is 8 ohms. So he is asking us to find the current flowing through this 8 ohm resistor. Okay, so there are two sources, one is voltage source, the other one is current source. So as we have learned in the source transformation that the internal resistance of an voltage source is nothing but 0 ohms. So it is replaced by a short circuit, and the internal resistance of the current source is nothing but infinite ohms. So it is replaced by a open circuit. So these two you need to remember to solve the problems using theorem. So let us go on with, so to find out the current flowing through 8 ohm resistor, we need to first consider one of the source and replace the other source by its internal resistance. So let me first find out the current in 8 ohm using 50 volts voltage source and replace the 5 amps source with its internal resistance. So I am just redrawing the circuit. Okay, so now considering first 50 volts source and replace 5 amps by its internal resistance. So what is the internal resistance of 5 ampere source? It is open circuit. Okay, so the circuit will be redrawn like this. So this is the current source which is now replaced by open circuit. This is 10 ohm resistor which is connected to the current source, and this is 8 ohm resistor where we have to find the current, and this is the 20 ohm which is given, and this is the 50 volt supply. So as we know that in open circuit there won't be any flow of current, so the current through this 10 ohm is 0 amperes. So the circuit can be redrawn as like this. Okay, so this is 8 ohms, this is 20 ohms, and this is 50 ohms. So as you can see here, the circuit is 20 ohms in series with 8 ohm. So the current which is flowing through this 8 ohm is nothing but the current flowing from the source. So it is this I. So I, we know from Ohm's law formula, V by R equivalent. So what is V here? It is 50, and R equivalent is 20 plus 8, 50 divided by 28, which gives us the current value of 1.78 amperes. Okay, so this is the value of current which is flowing through 8 ohm resistor when 50 volt source is considered alone. So I am rewriting this as current through 8 ohm resistors with 50 volts applied across it. So its value is 1.78 amperes. Okay, so this is regarding first source. Now consider with the other source. So let me draw the circuit. Now as we have already known the value of current due to 50 volts, now I will be replacing this with the internal impedance or internal resistance, and considering 5 amp source, I will be finding the current flowing through this 8 ohm resistor. So now the internal resistance of a voltage source is nothing but 0 ohm, so it is replaced by a short circuit. So let me draw this circuit again by replacing the voltage source with its internal resistance. Okay, so this is the 20 ohm, this is 8 ohm, and this is 10 ohm, and this is the source, current source. Okay, 5 amperes, 10 ohms, 8 ohms, 20 ohms, and this is the short circuit which is replacement of the 50 volt source, right? So here if you observe that the resistors 20 and 8 are in parallel, and that combination is in series with 10 ohms. And here you can also observe that the current source which is given is 5 amperes. That means we already have the total current. We need to find out the current flowing through 8 ohm so that we can find out the value of the total current using both the sources. Okay, so by using current divider rule, we are going to find the current flowing through the 8 ohm resistor. So as you can see here, we were assuming that the current flowing through 8 ohm was like downwards, so which is the opposite to the current direction which is given for this source. So we will be either you can take this like this, or you can also modify the circuit as follows. That means I am just reversing the direction of the current source, so the value will become minus 5 amperes. Okay, the value will become minus 5 amperes. So it is short circuit, 20 ohms, 8 ohms, and 10 ohms. So here the direction is being reversed. You can check here, it is downward here, so it is upward here. So the direction is reversed, so it is taken as minus 5 amps. Okay, now I am finding the current flowing through the 8 ohm resistor. So according to current divider rule, I am finding it. So current through 8 ohm resistor due to 5 amp source is equals to total current, that is minus 5, into opposite branch resistance. So the opposite branch resistance to 8 ohm is 20. So 20 divided by sum of the resistors. So 20 plus 8. So it is minus 100 divided by 28, whose value is nothing but minus 3.57 amperes. So the current due to 5 amps source alone is minus 3.57. The minus is because the direction what we have considered is opposite to the direction given to the source. Okay, now the total current through 8 ohm, total current through 8 ohm resistor is nothing but summation of two currents, that is current in 8 ohm due to 50 volt source plus current in 8 ohm resistor due to 5 amp source. So what is that current? The current due to 8 ohms was 8 ohms due to 50 volts was 1.78. So it is 1.78. 1.78 plus of, what is the current due to 5 amps? It is minus 3.57. So it is nothing but minus 1.79 amperes. So according to the statement of superposition theorem, when two sources are there, the response across any element is the sum of the responses obtained from each source considered separately. That means we have considered the sources individually, first as 50 volts and next with 5 amps, and then the other source is being replaced by the internal resistance, and then we are going to add both the currents or both the responses what we have obtained, so that we will be getting the final value of current which is flowing through that particular resistor with both the sources acting at a time. So moving on to the next question. This is the question given in 2018 May, and here the question is, using superposition find V0 in the circuit. So where is V0 located? It is located at the junction point of the circuit. So here you can see that as there is only one node connected here, so this node is the junction, and this voltage is to be calculated with reference to the ground. Okay, so V0 with reference to the ground we have to calculate. So in last problem we have seen about the current. Now we are going to learn about how to calculate the voltage. Okay, so similarly as in last problem, now we are going to consider one source at a time and replace the other source with its internal resistance and find out the voltage across the terminal given. Then add up the two voltages obtained, then you will be getting the total voltage across the terminal what they are asking. Okay, so let me start off with, we know that the internal resistance of the voltage source is nothing but 0 ohm, that is replaced by a short circuit. That means the voltage source is replaced by a short circuit. Okay, so now consider 9 volt source first. So replace 5 volts by short circuit. Okay, so redraw this circuit. That is, this is your 5 ohm, this is your 4 ohm. Okay, so this is 3. Now we are considering 9 volts, so it is being attached to the circuit. So here a resistance is connected, that is 1 ohm. This 5 volts should be replaced by a short circuit. This is a short circuit. This is 1 ohm. This is the V0 where he is asking with respect to the ground. This is 9 volts. This is 3 ohm. This is 4 ohm. This is 5 ohm. So here if you observe that the 4 ohm and 5 ohm are in 4 ohm and 5 ohm are in series. That series combination is in parallel with 3 ohm in series with the source, and that is in parallel with 1 ohm. So I am going to redraw the circuit. I am going to redraw the circuit like this. This is 3 ohm. This is a voltage source. So 3 ohm voltage source, 9 ohm, which is in parallel with 1 ohm. Okay, so this is 1 ohm, this is 5 plus 4, 9 ohm, this is 3 ohm, this is 9 volt source. So the R equivalent of this circuit is 9 in parallel with 1, which is in series with 3, because this two parallel combination will get a resistor as 1, and that resistor is in series with 3 ohm. So both are in series. Okay, so the value of this R equivalent is equals to, the parallel combination is 0.9 plus 3. So R equivalent is 3.9 ohms. Okay, so now actually I am going to calculate the current flowing through this source, so that I can know the voltage drop across this resistor, because this is the point where V0 I am going to calculate. Okay, which is nothing but the voltage across this 9 ohms, and the same voltage is across 1 ohm because they are in parallel. Okay, so let us find out the current. So current I is equals to V by R equivalent. So what is V? V is 9 and R equivalent is 3.9. So whose value is nothing but 2.30 amperes. Okay, now actually I am drawing the circuit again. So plus or minus. The parallel combination of 9 and 1, I am writing it as 0.9 ohms directly. This is 3 ohm, this is 9 volts. Okay, so this is nothing but the voltage across this point. That is nothing but the voltage across 0.9. Okay, so what is the current flowing through the source? So the current flowing through the source is 2.30. So as we have known the value of current as 2.3 amps, now we are going to find the value of V0 with respect to ground. Okay, so here we can find it in two ways. One is, let me write here plus and minus. So it is nothing but the voltage at 0.9 ohm, or it is the voltage which is total supply voltage minus the drop across 3 ohm. Okay, so let us draw the direction of current, that is I, which is like this. So plus minus. Okay, so V0 is equals to, it is the voltage across 0.9 ohm. So it is I into 0.9. So it is 2.30 into 0.9, which is nothing but 2.1 volt. Okay, similarly, it can also be found out by using this drop. So as we are going to consider the value of V0 with respect to ground, so we are going to find the voltage across this combination, that is minus 3 into I plus 9. Okay, minus 3 into I plus 9, which is nothing but your V0. So V0 equal to minus 3 into I plus 9. So minus 3 into 2.3 plus 9, whose value is nothing but minus 6.9 plus 9, whose value is given as 2.1 ohm. So either ways you can find out the value of voltage of V0, either by using this combination or by using this voltage across the 0.9 ohm resistor. Okay, so V0 with respect to 9 volts is nothing but 2.1 volt. This is first answer what we have obtained. So now we are going to consider 5 volt voltage source and replace the 9 volt source by Earth's internal resistance, that is short circuit. Okay, so this is 5 ohm resistor which is in series with 4 ohm, and this is connected to 3 ohm resistor with short circuit of 9 volts, and it is connected to 1 ohm resistor with a voltage source of 5 volts. Okay, so this is 5 volts, this is 1 ohm, this is 3 ohm, this is the short circuit of 9 volts, this is 4 ohm, and this is 5 ohm. So here you can see that 4 ohm and 5 ohm are in series. So the series equivalent will be 5 plus 4, it is 9, which is in parallel with 3 ohm, and that combination is in series with 1 ohm. So I am just going to redraw the circuit. Okay, so this is 9, this is 3, and this is 1. Okay, so 5 volts, 1 ohm, 3 ohm, and 9. So the equivalent resistance of 3 and 9, the equivalent resistance is nothing but 9 in parallel with 3, and that is in series with 1. So this value is 2.25 plus 1, so it is 3.25 ohm. So R equivalent value is 3.25 ohm. Now find out the current, that is, this is 3.25 which is connected to the supply. So this is 5 volts, this is 3.25 ohm. So find out the current I. So I equal to V by R equivalent. So V by R equivalent means 5 divided by 3.25, whose value is nothing but 1.53 amperes. Okay, 1.53 amperes. Now you can see that in this circuit the current here is 1.53 amperes. Either you can find out by using current divider rule the current flowing through 3 ohm and find the voltage across this 3 ohm resistor, because this is the V0 what we have to find out. Okay, or else you can also do that this combination, that is 9 and 3 are in parallel, that combination is in series, so you can also draw the circuit like this. That means I am just doing the parallel combination of 9 and 3 into one resistor, because the V0 is nothing but the voltage across this resistor. Okay, voltage across this resistor. So 2.25, and this is 1 ohm, this is 5 volts, and we know that the current flowing here is 1.53 amperes. So the voltage V0 is equals to current I into 2.25. So what is that I? 1.53 into 2.25, whose value is nothing but 3.42 volts. 3.42 volts. So this is the voltage across 3 ohms, that is V0, what we have found due to 5 volt source. V0 due to 5 volt source. So to get the voltage what it is been asked in question, so we should add two voltages, that is voltage because of 9 volt source plus voltage because of 5 volts. So voltage because of 9 volts was 2.1, and now voltage because of 5 volts is 3.42. So whose value is nothing but 5.52 volts. This is the total voltage across the terminal asked in the question. Across the terminal asked in the question, that is the voltage here due to two sources, that is 9 volt and 5 volt, is 5.52 volts. Okay, so this is the latest problem which is given for 15 marks. So the question is, find the current in 60 ohm for the circuit in the following figure. So first find where is 60 ohm connected. It is connected across the terminals A and B. Okay, so here we are going to find the current. Okay, in this 60 ohms we are going to find the current. Okay, so how many sources are here? There are two sources. One is 9 volt and the other one is 1.8 ampere. Okay, so don't get panicked after seeing the circuit. It is just a simple circuit, but it is being shown as complex. Okay, if you know the statement of the theorem very clearly, then you can solve any kind of problem given in the examination. So what does the statement state for superposition theorem? First, we need to consider individual sources, then add the response of both the sources, and we'll be getting the response which is asked across the element. Okay, so we know that the internal resistance of the voltage source is 0 ohm, so it should be replaced by a short circuit. And we know that internal resistance of the current source is nothing but infinite ohm, so it should be replaced by an open circuit. So why it should be replaced by open circuit? Because as current is inversely proportional to resistance, as resistance is infinite, then what is the value of current? It should be 0. So if 0 is the current flowing in the circuit, then it is known as open circuit. Okay. Similarly, short circuit. If the resistance is less, then current will be high. So 0 resistance, so it will be a short circuit. That means high current will be flown through the circuit. Okay. So let us now consider 9 volt source and replace 1.8 amperes source with its internal resistance. So I am going to redraw the circuit here. Okay, so now consider 9 volt source and replace 1.8 amp source by what? By open circuit, because it is a current source. Okay, so I am drawing the circuit here. So this is the voltage source 9 volts. This is the resistor 5. This is the resistor 25. And this is the open circuit. Okay, so this is the resistor 60 ohms, and there is one more resistor here, that is 10, and here it is 20. Okay, so this is terminal A, B, 60 ohms, 20 ohms, 10 ohms, 25 ohms, 5 ohms, and 9 volt source. So due to the open circuit of this current source, now you can see that the circuit of 5 ohm and 25, the connection of 5 ohm and 25 is now series. Okay, it is now in series connection, that is this 5 and 25 are in series, so it will add up to 30 ohms, and that is in parallel with the series combination of 20, 60 and 10. 20 plus 60, 80, 80 plus 10, 90. So 30 is in parallel with 90 across the voltage source of 9 volts. So I am going to redraw this circuit. Plus minus. This is like this. 9 volts, 30 ohm, that is 5 plus 25, and 20 plus 60 plus 10, it will give you 90 ohm. Okay, so the R equivalent for this value is 30 in parallel with 90. So it will equal to 22.5 ohms. 22.5 ohms. This is the R equivalent of this circuit. Now find out the total current flowing through the circuit. So what is the total current flowing through the circuit? That is I equal to V by R equivalent. So what is V? V here is 9 and R equivalent is 22.5. So the value of the current is 0.4 amperes. Okay. Now we need to know the current flowing through 60 ohm resistor. So here the current flowing through 60 ohm resistor is the same current flowing through 20 ohm and the same current flowing through 10 ohm. That means these are in series. That is nothing but the current flowing through the 90 ohms is the current flowing through the 60 ohm. So by using current divider rule, we can find out the current flowing through this circuit. So as we have found that this current is 0.4 amperes. So by using current divider rule, I am going to find out the current flowing through 60 ohm. I am mentioning here it as 60 because it is the same current flowing through all the resistors. Okay, it is the same current flowing through all the resistors. For your reference, I am drawing the circuit again. For your reference, I am drawing the circuit again. This is 30 ohm, that is 25 plus 5. This is 20 ohm. This is 60 ohm. This is 10 ohm. Okay, so this is the current which I have mentioned as I60 ohm. Okay, that is the same current flowing through 20 ohm and 10 ohm. So we know that total current is 0.4 amperes. This is the voltage 9 volts. So according to current divider rule, I60, that is 60 ohm current, is equals to total current into opposite branch resistance. So what is the opposite branch resistance of this combination? It is 30 divided by total resistance, that is 30 plus 90. So this value is nothing but 0.1 amperes. Okay, so the current in 60 ohms due to 9 volt source is 0.1 amperes. This is the first thing we have found out due to one voltage source. Now I am going to replace the 9 volt source with the internal resistance, that is short circuit, and now we are going to consider 1.8 amperes current source. Okay, so I am going to redraw the circuit again here. So this is the 9 volt source which is replaced by short circuit. To this there was 5 ohm resistor, to this there was 25 ohm resistor, and here the current source is being given, and here we have 10 ohm resistor, here we have 60 ohm resistor to terminals A and B, and here we have another resistance that is 20 ohms, right? So 20 ohms, 5 ohm, 25 ohm, 1.8 amperes current source, 10 ohms and 60 ohms, right? So this is the circuit as mentioned. So if you observe the circuit carefully, if you observe the circuit carefully, the resistor 5 ohm and 25 ohm are connected between two common points, that is this point and this point, so they are in parallel. Okay, this is now connected in parallel with the series combination of 10 and 60, 10 and 60, and that is in parallel with 20 ohm. Okay, so I am going to redraw the circuit here. This is 20 ohm. Okay, so this is 5 ohm, this is 25 ohm, which is connected to 1.8 ampere source. This is 10 ohm, this is 60 ohm, which is connected like this. Okay, which is connected like this. This is the terminal A and this is the terminal B. But we only want the current flowing through 60 ohm. So you ignore the terminals A and B. Okay, so this is 10 ohm, this is 5 ohm, this is 25 ohm, this is 20, and this is 1.8 amperes. So here you can see that this parallel combination of 25 and 5 ohm will add up to the current, that is 1.8 amperes, because according to KCL we know that sum of the current entering the node is equals to sum of the current leaving the node. So even though we don't know the current flowing through 5 ohm and 25 ohm, we can know the value of total current as 1.8 amperes. Okay, and again here the 20 ohm is in parallel with the combination of 60 and 10. Okay, the series combination of 60 and 10, that is 70, is in parallel with 20. So I am going to draw this circuit for your reference. Okay, so here you can see this is 5, this is 25, this is 1.8 amperes. Okay, so this is 20 ohms, because all the are connected between common terminals, so you can redraw it as you wish to draw, but the answer should be same. Okay, so it is 60 plus 10, that is 70 ohms. Okay, so this 1.8 ampere is now being passed through this junction and it is being divided into 20 ohms, the resistor in 20 ohm, so the current flowing through 20 ohm, and the current flowing through 70 ohm, which is a combination of 60 and 10. So we want the current flowing through this 70 ohm. So we want the current flowing through this 70 ohm. So by using current divider rule, I am solving it. Okay, so according to current divider rule, so to know the current flowing in 70 ohm, which is nothing but the current in 60 ohm, because it is a combination of 60 and 10. So the total current into opposite branch resistor. So what is the opposite branch to 70? It is nothing but 20. So 20 divided by 70 plus 20. So the current is 1.8 into 20 divided by 90. So it is nothing but 0.4 amperes. okay, 0.4 amperes. So this is the current in 60 ohm resistor due to 1.8 amps, due to 1.8 amps source. Okay, so we have found out two currents with respect to two sources. One is voltage source and the other one is current source. So now we are going to summate the total current which is flowing through 60 ohm resistor. So I 60 ohm, that is total, is nothing but current flowing in 60 ohm due to 9 volt source plus current flowing through 60 ohm resistor due to 1.8 amperes. So what was the current flowing through 60 ohms due to 9 volt source? It is 0.1 and here it is 0.4. So the summation of both the currents will give you the total current flowing through 60 ohm source when both the sources are applied. When both the sources are applied. So this is the question which was asked, that is, find the current in 60 ohms. So by using individual voltage and current sources, we have found it out, and by adding we will be getting the total current flowing in the 60 ohms. So, and one more thing here I want to mention is that always in superposition theorem, we can get the value of current and voltage as same when calculated by individual voltage or current sources, but we can't get the power as same for calculating with individual sources. This will be known in our next video. So please subscribe to our channel.